Hello, my name is Robert Scott, and I've been working under Dr. Joy Winbourne in an analysis of the health of street trees in Boston, Massachusetts. Here are a few key terms that will help in understanding our project. Tree health allows for trees to grow and thrive unimpeded by outside factors. The trees we analyzed are street trees, which are planted adjacent to municipal roads. The urban heat island effect is the tendency for urban areas to be hotter than non-urban areas. And it is important to know that trees have the potential to cool the surrounding air by blocking direct sunlight via shade or through the transpiration of water. As alluded to, trees have the potential to act as natural, sustainable cooling systems in urban areas through shade and transpiration. As such, many cities have begun to prioritize the planting of trees within their municipalities to mitigate the urban heat island effect, such as Boston's newly founded urban forest plan. Not only can this provide greater comfort on hotter days, it also helps to avoid heat-related deaths that tend to affect the oldest and youngest among the population. In fact, the National Weather Service cites heat as the leading cause of weather-related death in the U.S. To help avoid these outcomes, policymakers need to ensure urban trees are in good health so they can survive, grow, and contribute to urban cooling. With this established, our question for the project was how did the rates of urban tree growth, mortality, and recruitment measure across Boston neighborhoods? These act as proxy measures for the general health of the city's trees. To investigate this, we used a unique method of merging, cleaning, and comparing two street tree inventories taken in Boston in 2006 and 2021. We have progressed through 3 neighborhoods so far, totaling over 6,000 usable data points. We found the mean growth rate for Boston street trees was 0.42 centimeters per tree per year in our observed neighborhoods, which is about half the mean growth rate that was observed in a previous study conducted among a smaller sample of Boston street trees between 2006 and 2014 by Smith and colleagues. We also found a much larger variation in the growth rate than in that study, though the mortality rate we found was within Hilber and colleagues' observed range in their review of urban tree mortality. The recruitment rate indicates that almost half the trees we analyzed were planted between 2006 and 2021, and we found that 84% of the trees that died in this period were replanted. These two statistics indicate a large amount of trees were either planted or replanted in these neighborhoods between 2006 and 2021. So what can we draw from this? The high recruitment and replacement trends indicate that there has been considerable effort in the past 2 decades in Boston to not only plant more street trees, but to also replace dead ones. But the highly varied growth rates and moderate mortality rate that we observed call the health of these planted trees into question. This suggests the need for measures that ensure street trees in Boston are being properly cared for to maximize their health, growth, and cooling potentials, which the City of Boston is currently working on with their urban forest plan. We hope to gain a broader perspective after analyzing all Boston neighborhoods, which will allow for a more detailed and specific analysis of problem areas in the city. Thank you for listening.